Okay, catalysts. Catalysts speed up a reaction without being consumed by the overall reaction. So you should always be able to get your catalyst back at the end of the reaction. How do they do this? How do they speed up the reaction? They offer an alternative pathway or an alternative mechanism, but it's still a pathway here because we're looking at an entropy pathway diagram, profile diagram, sorry. But here we've got two pathways. So this one here, the first one, the one on the top, is the pathway of the reaction that occurs when there's no catalyst. So EA represents the activation energy. The second smaller one underneath is what happens when you use a catalyst. Okay, so EC is the activation energy with a catalyst. So we can see that catalysts lower activation energy. So a small amount of energy is needed for a reaction to occur. So you've got two pathways there. So when you label these, delta H always stays the same, but the EC and EA vary because we've got two different pathways. So why do we want to use catalysts? Well, because activation energy is lower, we can use lower temperatures, and that reduces energy demand, so we have to buy less fuel, and that means we're reducing the amount of emissions from burning that fuel as well. Also, catalysts, when they give this alternative pathway, often that new pathway leads to better atom economy, and if you have better atom economy, it means you've got less waste products to have to deal with as well. These factors here combined lead to greater profitability for a company. Okay, so looking at types of catalysts, we have heterogeneous. So heterogeneous catalysts are ones where the catalyst is in a different physical state to the reactants. So an example would be the use of iron in the Haber process. The reactants in the Haber process are nitrogen gas and hydrogen gas, and iron is a solid metal. Homogeneous ones, they have the same physical state as the reactants. So an example of this, a lot of times when we use acids as catalysts in solutions, all the reactants will be in solution, including the catalyst, so it'll be the same physical state. Another type of catalyst, or sort of catalyst, is an enzyme. An enzyme is a biological catalyst. The big advantage of using an enzyme is that enzymes operate at temperatures and pressures that at room temperatures and pressures, so very low temperatures and pressures, so they're very cheap to use. Okay, if you go to high temperatures, they'll denature and won't work. So they offer a very cheap alternative if you can find the right one for the right reaction, because they're specific. They can't just be used in any reaction.